In this video, we'll be talking about vectors and give a couple of examples and talk about their magnitude and direction. A vector is basically a physical quantity with a magnitude and direction. Now, what does that mean? For example, if we talk about a velocity vector, velocity is the speed of an object with a direction. So 60 miles an hour to the east. The magnitude or the amount would be 60 miles an hour. The direction would be east. A force vector, an example of that would be 15 newtons to the right. It tells you how much force is exerted and the direction in which it is exerted. Magnitude, the word, just means the amount or the absolute value of the vector. Visually, it is the length of the arrow, and it's proportional to that amount. The vector components, which we'll get into in a moment, are when vectors point in two directions, and we have to look at the amounts of each of those parts. So, for example, which two vectors have the same magnitude? If we look at vector A is 6 blocks to the right. Now, vector B goes to the right and up, so we're going to use components, or the perpendicular parts of vectors, to compare them, because we know the rules of right triangles. This will help us draw comparisons between magnitude and direction. So it goes 4 units to the right and 6 units up, which means if you were to figure out the magnitude of vector B, this would be 4 squared plus 6 squared, or radical 52, or 7.2 units up and to the right. For our purposes right now, we probably just can use the components to compare amounts. We don't actually have to go through this process and figure out the actual magnitude of each vector. So vector C we'll have a component going down 4 and to the left 2. Vector D will have a component going down 7 and left 2. Vector E will have just an amount going straight up, which would be 6. And vector G will go down 8 and to the left 4. Now, when they ask to compare vectors with the same magnitude, they have to be the exact same magnitude. So if I look at something like vector B, which is radical 52, and I look at something like vector D, which is 7 squared plus 2 squared, which would be radical 53, they are close, but they are not the same magnitude. The only two vectors that have the same magnitude are A and E. They are both 6. When they're asking that question, they're referring to precise values. Okay, which two vectors have the same direction? Now, if we look at this, we can see that, I forgot about vector F. Vector F has an amount of 3, a magnitude of 3. All right, so as far as vectors with the same direction, okay, they must have the precise same direction. The angles must be the same relative to the reference frame. So looking at this, the only two with the exact same direction would be C and G. They both have components that are proportional to each other. So when you look at the tangent of this angle in here, let's call X for now, and I look at the tangent of X in here, I'm going to end up with opposite over adjacent, 4 over 8 for G, and for C, 2 over 4. So the only two with the exact same direction are C